All right, let's take a look at some examples and how we do this in R. A couple of different commands here. This command is similar to the ones that we've seen before. The only difference is now we're dealing with pairs of scores. So we have to specify two different variables. The command core, data set, $, whatever the X variable is, data comma, data set, $, whatever the Y variable is the basic format. We also have a command called core test, which gives us some extra information that we'll talk about later in the semester. I tend to use core test rather than core. Both of them are fine for the correlation assignment. And then plot. The plot command gives us a scatter plot. So again, we're seeing most of the commands that we use in this class are pretty straightforward. This plot command, you can add titles and all of those things that we've seen before as well. Here's a graph of the relationship between stress and negative psychological symptoms people present with at a counseling clinic. You can see using core test, we got a lot of information. The correlation's down at the bottom. The graph here shows that as stress goes up, negative psychological symptoms go up, not surprisingly. And the size of this relationship is about 0.51 or so in terms of its strength. One thing that we'll see is the larger the correlation, the more clear these graphs become, the more we can see a pattern. The less we can see a pattern, the weaker the relationship. Here's test anxiety and exam performance, which we saw before. Here we have a negative correlation of 0.68, meaning that as test anxiety goes up, exam performance goes down. One thing I should mention here is one thing I'm really interested in this class, and this is really the first place where we start to see this, is people interpreting findings in what I refer to as plain English. What that means is you're not saying things like there's a negative relationship between these two variables. You're saying things that describe the relationship in a way that somebody who hasn't had a statistics course could understand. As test anxiety goes up, people do worse in their classes, would be a good plain English interpretation of this. I really stress that in all of my classes because being able to communicate what the statistics mean is a huge skill, and it's something that's incredibly valuable. All right, here, test anxiety at time 1 and time 2. We see a really strong relationship here. This looks almost like a straight line. We can see this correlation is actually 0.99. It's almost close to that 1.0, or what would be a perfect correlation. People's scores, both times they took the scale, were very stable, is a good interpretation there. Age and job seniority at a new company. We saw this graph before, and we saw that we really don't see any pattern. There's a small positive correlation of 0.05, but again, we see the smaller the relationship, the less of a pattern that we actually observe. All right, to give you a sense of the size of different correlations, I'll show you a few of them, a few correlations. SAT scores, something that's become very controversial lately. SAT scores and first-year college grade point average. Keep in mind that SAT scores relate to the first-year college GPA, but they're really unrelated to anything that comes after that. The reason being is, people are taking the SAT at such a young age, and there's a lot of development going on cognitively. SAT reports a correlation of about 0.47 between SAT and first-year college GPA. It probably taps not intelligence, but some sort of ability to focus and study. Smoking and lung cancer. This has to be a gigantic correlation. I mean, I haven't seen a pack of cigarettes in a while, but it says basically on the damn things, this shit will kill you. They have to put those warning labels on there. So it's got to be a giant relationship, right? Yeah, it's actually only about 0.40. So there is a relationship. It's not everybody who smokes is going to die, but it is a substantial relationship. All right, exposure to media violence, particularly violent video games and aggression in adolescence. Correlation is about 0.32, so relatively low if you're thinking about it in an absolute sense, but pretty reasonable to say that adolescents shouldn't be exposed to media violence, to violent video games. Of course, I say this as my son is in the other room playing Fortnite. Self-examination and detection of breast cancer. Higher numbers here mean later detection. Smaller numbers mean earlier. The relationship here is negative 0.07, which might again seem small, but again, we have to ask, okay, what is the cost of self-examination and detection of what is the cost of self-examination? All it costs is a little bit of education to know what to look for. So very low cost intervention. Again, when something doesn't cost much, it doesn't have to demonstrate gigantic results. Okay, exposure to lead and IQ scores in children. Lead is bad for kids. In fact, the paint industry had to remove lead from all of its products. It used to be something that you would have in paint. Paint was actually a lot better then, but it was very bad for you. One of the reasons why they had to remove paint is that lead can lead to cognitive deficits. You can see the correlation here is also relatively small, but if you're talking about being in that group that maybe is stupider because you were given water because you had exposure to lead, then it is very meaningful. And I want to ask, what if the SAT GPA correlation was 0.07? Would you see schools using it still then? Probably not. Given the cost, given the industries around it, you probably definitely would not see the SAT score being used. All right, now that we're getting into some techniques that people use, I'd like to use this opportunity to bring in examples from published work. This is a really interesting study by Rosalie Corona and her colleagues. She's a professor of psychology at Virginia Tech. She directs their Latino mental health clinic. If you want to know about her research, her general area of research focuses on health promotion and risk reduction in Latina and African American families. She's primarily interested in identifying family and cultural protective factors and evaluating family-based interventions. So it does really awesome applied work that's directly related to improving healthcare outcomes. This is a table from one of her articles that appeared in the Journal of Youth and Adolescence. What this is a table of correlations between a bunch of study variables. The primary variable here that we'll talk about is familism, the idea that you put family above yourself. Endorsement of familism is related to, if you look at these last three values, it has a negative relationship to depression, to anxiety, and to stress. So really promoting those ideas of familism, that your family is the most important thing, is related to better psychological outcomes, less depression, less anxiety, less stress. Really, really useful and meaningful type work. So again, just an example of how correlations are used. You'll often see studies which have a lot of variables, which measure a lot of things, because if you're going to bring somebody in and follow them and do research on them, you don't want to measure just one or two things. So you can see those relationships here, and it's typically expressed in terms of a table of this nature, which is basically a matrix of the variables. All right, that's it for this section on correlation. The next section expands on this and gets into what's called linear regression, which we'll see uses a lot of the same constructs as correlation, but it's really opens the door to new and very useful techniques.